Chapter 15, Lesson 1. What is motion? All kinds of things around you move in different ways. Cars, trucks, and buses transport people and goods from place to place. You can describe and measure their motion in different ways. The illustration says, toy cars change speed as they race around the track. Sometimes the cars move in a straight path. Sometimes the cars move in a curved path. Under the heading Types of Motion, different things move in different ways. One way objects can move is in a straight line. A baseball player racing for home plate is likely to run in a straight line. Trains on a track often travel in straight lines. Objects can also move in a curved path. A car turning a corner moves in a curved path. Curved motion takes place around a center point. A bicycle wheel follows a curved path around its axle. Earth moves in a curved path around the sun. Another way things can move is back and forth. When a player plucks a guitar string, the string moves back and forth. This back and forth motion is known as vibration. But as you ride your bicycle or walk down your street, you pass plants, buildings, and other things that do not move. They are fixed in place. When you pass a fixed object, you know you are moving. When you stand still, you can tell that a car you see moves because it changes position. Your understanding of motion is related to the things around you. Every day you compare objects that change position with objects that don't. The change in one object's position compared with another object's position is relative motion. Number 1, checkpoint. What are 3 different types of motion? Number 2, sequence. Describe the sequence of events of the yellow race car as it travels around the track above. The words under the first picture. From your frame of reference on the sidewalk, the bus and the people on it are moving. The heading under the second picture. From your frame of reference on the bus, everything on the bus seems to be standing still. And the words under the third picture. From your frame of reference on the bus, if the bus moves, everything outside it seems to move. At the very top of the page, how you know you are moving. How do you know if a person on a water slide moves? How do you know if the water moves? You look at the changing positions of the person and the water. You compare their changing positions with the fixed position of the slide. You use the relative motion of the objects around you to decide what is moving and what is not moving. Next paragraph. Objects that don't seem to move define your frame of reference. How an object seems to move depends on your frame of reference. Your frame of reference is like your point of view. Next paragraph. Suppose you are on a float in a parade. Your friend is on the same float. The float begins moving down the parade route. You wave at the people sitting and watching the parade as your float moves past them. From your frame of reference on the float, the people seem to be moving, but your friend hasn't moved a bit. From your friend's frame of reference, you haven't moved either. As the parade moves down the street, people on the sidewalk see you and your friend pass by. From their frame of reference, you and your friend are both moving. Suppose you use your classroom as your frame of reference. If you were sitting at your desk, you would say that you are not moving. But suppose you choose the sun as your frame of reference. Now you would say you are moving because Earth carries you along with it as it travels around the sun. The next heading, measuring motion. Speed is the rate at which an object changes position. It measures how fast an object moves. The unit for speed is a unit of distance divided by a unit of time, such as kilometers per hour. A car moving at a high speed changes position faster than a car moving at a slow speed. To find an object's average speed, divide the distance the object moves by the total time spent moving. The next page. Velocity combines both the speed and the direction an object is moving. Some words that describe direction are north, south, east, and west. Others are left, right, up, and down. Any change in the speed or direction of an object's motion is an acceleration. Starting, speed up, and slowing down are accelerations. The roller coaster accelerates as it speeds up. It is changing speed. A roller coaster on a curved path accelerates even if its speed does not change. That is because it changes direction as it moves around the curve. Lesson checkpoint. Number 1, what is a frame of reference? Number 2, what are 2 ways that a roller coaster can accelerate? Number 3, writing in science. Descriptive. Write a paragraph in your science journal that describes the difference between speed and velocity. Next, we have a picture of a roller coaster. The roller coaster slows as it moves up to the top of the loop. It goes faster heading downhill. The velocity changes as the coaster changes direction from up to down. This roller coaster reaches its greatest speed at the bottom of the loop.